All right, so we're diving into some really cool stuff today.
Mhm.
It's all about this o1 model that's making some serious noise in the AI world. Basically, we're talking about AI going from like thinking super fast to thinking much deeper and more deliberate, almost like how we humans solve complex problems.
Yeah, and you know what's really fascinating about this is we got this paper that people have been buzzing about. It's trying to actually recreate O1 and understand how it works, especially when it comes to tasks like coding, which is, really pushing the boundaries of what AI can do.
Right, because up until now, a lot of AI has been, like you said, super fast, but not necessarily understanding the why behind what it's doing. It's been more like just giving quick responses based on the data it's been trained on.
Exactly. It's like a super calculator,
Yeah.
Really good at crunching numbers and spitting out answers, but not really grasping the concepts behind it all.
So how does this o1 model change that? What makes it different?
Well, to understand that, we need to think about how we humans think. We have these two systems of thinking that scientists talk about, system one and system two.
Okay, yeah, I've heard of that. Like system one is our gut reactions, right?
Yeah.
Fast, intuitive, based on instinct.
Exactly, like when you touch a hot stove and pull your hand away instantly. That's system one. No deep thinking involved, just pure reaction.
And then system two is more like when we're trying to solve a puzzle or write a paper. It's slower, more deliberate, and requires us to analyze information step by step.
Exactly, and that's where O1 comes in. It's getting closer to the system two thinking by combining two really powerful techniques, pre-training and reinforcement learning.
So pre-training is kind of like giving the AI a massive library of information to work with, right? Like loading it up with all the knowledge it might need.
Yes. Think of it as giving the AI access to a vast library full of books, articles, and code, all the information it could ever need.
And then reinforcement learning is how it learns to use that information effectively, right?
Yeah.
Like it's experimenting, figuring out what works and what doesn't.
Precisely. It's like giving a kid a bunch of Legos and letting them figure out how to build stuff. They might start with random structures, but over time they learn which pieces fit together, how to build stronger towers, and eventually they can create amazing things.
I see. So it's not just memorizing facts, it's learning how to apply them, almost like learning from experience.
Exactly. And that's where this paper we're talking about gets really interesting. The researchers decided to focus on coding as the task to really test O1's capabilities. Because coding, it truly requires system two thinking.
Yeah, makes sense. Coding is all about breaking down a problem into logical steps and creating a solution based on a set of rules and instructions.
Yeah.
It's not something you can just do intuitively.
Right. But teaching AI to code presents some unique challenges too.
Yeah.
First, how do you evaluate the code that AI writes without needing a human to check it all the time? And second, how do you make sure the AI isn't just spitting out random code, but actually thinking through the problem like the human programmer would?
Those are really good points. It's one thing to have AI write code, but it's another thing entirely to have it understand what it's doing and why. So how did the researchers address these challenges?
Well, they came up with some pretty ingenious solutions, actually. For evaluation, they built this separate AI tool called a test case generator, or TCG. It's basically an AI system that creates tests to check the other AI's code.
So it's like an automated teacher grading the AI's homework.
Exactly. It checks if the code produces the correct output for different inputs and gives feedback. This way, they don't need a human to manually check every single piece of code the AI writes.
That's pretty smart. And what about the second challenge? How do they ensure the AI is actually reasoning through the problem and not just randomly generating code?
Well, for that, they introduced this concept of think before acting. Instead of just jumping straight into writing code, the AI is first required to create a detailed plan in something called pseudocode.
Pseudocode. I'm not familiar with that.
It's basically a simplified version of code that's more human readable. Think of it as an outline for the actual code. It forces the AI to slow down and think through the logic of the solution before it starts writing the actual code itself.
So it's like forcing the AI to think step by step, like a human programmer would do when tackling a complex problem.
Exactly. And this think before acting approach actually has some really neat benefits. It makes the AI more flexible because the same pseudocode can lead to different ways of writing the actual code. And it also gives the researchers more control because they can adjust how detailed the pseudocode needs to be, which influences how deeply the AI reasons about the problem.
That's really interesting. It's like they're giving the AI training wheels, but also the ability to take them off and ride on its own when it's ready.
Yeah, that's a great way to put it. And this is where the paper really dives deep into the training process for both the test case generator and the main AI model that actually writes the code.
Okay, so let's talk about that training process. How do they actually teach these AI systems to do what they do? What techniques do they use?
Well, they used a combination of supervised fine-tuning and something called direct preference optimization, or DPO.
DPO, that rings a bell. Can you remind me what that is?
Sure. DPO is basically a way to train AI models by giving them feedback on which outputs are preferred. It's like showing an AI a bunch of paintings and telling it which ones you like better. Over time, it learns to generate outputs that are more aligned with your preferences.
Ah, okay, I see. So in this case, they use DPO to train the test case generator to create test cases that effectively evaluate the quality of the AI's code.
Exactly. And they also used it to train the main AI model to generate code that's more likely to pass those tests.
So they're not just teaching the AI to write code, they're teaching it to understand what good code looks like.
Hmm.
And they're teaching the test case generator to do the same thing when it comes to evaluating code.
Precisely. It's like having two AIs learning from each other, one learning to write code and the other learning to critique it. And the results they got were pretty remarkable.
Oh, yeah. What kind of results did they see? Was the AI actually able to write good code?
Well, they found that the test case generator achieved a high pass rate on standard test cases, meaning it was actually quite good at evaluating the quality of code. And the AI model itself was able to generate code that passed those tests in many cases.
That's amazing. I mean, you were talking about AI systems learning to code and grade each other's work. It's like something straight out of science fiction.
It really is. And it makes you wonder if they can achieve this level of sophistication now, what will they be capable of in the future?
It's mind-blowing. And that brings us to another fascinating aspect of the O1 model that I'm really curious to explore. Self-play.
Self-play. Ah, yes, that's where things get really exciting. So tell me, are you familiar with the concept of self-play in AI? Well, it's kind of like, when AI plays games against itself, like in chess or Go.
Yeah, I've heard of that. Like AlphaGo, right?
Hmm.
It got so good by playing millions of games against itself.
Exactly. And that same concept can be applied to other tasks like coding. In this case, the AI is basically generating code, evaluating it using that test case generator we talked about, and then learning from its mistakes. It's a continuous loop of practice and improvement.
So it's like it's constantly challenging itself to get better.
Hmm.
But how does this think before acting approach fit into all of this?
Oh, well, that's the key. Remember how we said the AI creates a detailed plan in pseudocode before writing the actual code?
Yeah, it's like outlining an essay before you start writing.
Exactly. Well, in self-play, that pseudocode becomes really important because it's what the AI uses to reason through the problem. It's like the AI is having a conversation with itself. Okay, what's the best way to solve this? What are the steps I need to take?
So it's not just about blindly generating code. It's about actually thinking through the problem step by step.
Precisely. And the really cool part is that each time the AI goes through this process, it gets feedback on how well it did. Remember, the test case generator grades its work and gives it a score.
So the AI learns from its mistakes and tries to do better next time.
Yes, it's like a constant feedback loop. The AI generates code, gets graded, figures out what it did wrong, and tries again. And over time, it gets better and better at both writing code and reasoning through the problem.
This is fascinating. It's like watching a kid learn to ride a bike. They fall down a few times, but they get back up and eventually they figure it out.
Yeah.
But they mentioned something called process rewards. How do those play into self-play?
Ah, yes, the process rewards. That's where it gets even more interesting. The researchers realized that just rewarding the AI for writing code that passes the tests wasn't enough. They wanted to encourage the AI to actually develop good reasoning skills, even if it didn't immediately come up with the perfect solution.
So it's like giving partial credit for showing your work, even if you didn't get the final answer right on a math test.
Exactly. It's about rewarding the process of thinking, not just the final outcome. So they introduced these process rewards, which are given for each step in the reasoning process.
So the AI gets points for thinking things through logically, even if the code itself isn't perfect yet.
Precisely. And they actually have a separate AI system called a process reward model, or PRM, that evaluates the quality of each step in the reasoning process.
Wow, so it's like having an AI coach that's watching the AI coder think and giving it feedback on its thought process.
Yeah, it's like having a coach who can analyze the AI's game plan and say, okay, that's a good strategy, even if it didn't lead to a win this time.
I'm trying to wrap my head around all of this.
Yeah.
It's incredible how intricate these systems are. But it makes me wonder, how do they even train these AI systems to do all of this?
Yeah.
Like, how do they teach the process reward model to evaluate the quality of reasoning?
That's a really good question, and it's one of the most challenging parts of this whole process. Training the process reward model is a bit like, how a sports coach develops their expertise by watching countless games and analyzing different strategies?
Yeah, they learn to recognize patterns and see which strategies are more likely to lead to success.
Exactly. Well, it's kind of similar with the process reward model. They train it by showing it a lot of examples of different reasoning paths that the AI could take to solve a problem.
And then they try to figure out which paths are more likely to lead to a successful outcome.
Yes. It's a bit like analyzing game film and trying to figure out which plays are more effective, but instead of a human coach doing the analysis, it's an AI system.
Wow, this is so cool, but it's
Mhm.
also making my brain hurt a little. It's like trying to understand the inner workings of a really complex machine. We've been talking a lot about the technical details, but I'm also really interested in the bigger picture. What are the implications of all this? How might o1 and models like it change the world?
Yeah, that's the really exciting part, isn't it? We're talking about AI that's not just mimicking human behavior, but actually developing its own ways of thinking and problem solving. The possibilities are pretty much endless.
It's like we're witnessing the birth of a new kind of intelligence. What does this mean for the future of work? Will AI take over all our jobs?
That's a question that a lot of people are asking, and it's a valid concern. But the authors of this paper believe that AI is more likely to augment human capabilities rather than replace us entirely.
So it's more about collaboration than competition, like AI and humans working together to achieve things that neither could do alone.
Exactly. And they also emphasize the importance of transparency in AI development. We need to be able to understand how these systems work and how they arrive at their conclusions. That's crucial for building trust and ensuring that AI is used responsibly.
That makes sense.
Yeah.
We don't want AI to be a black box that we just blindly trust.
Yeah.
We need to be able to see what's going on inside and understand its reasoning.
Huh.
So how does the o1 model address this issue of transparency?
Well, one of the really cool things about o1 is that we can actually trace its thought process step by step because of that think before acting approach.
So we can see the pseudocode that the AI generated as it was reasoning through the problem.
Exactly. It's like having a window into the AI's mind. We can see how it broke down the problem, what steps it took, and why it made the decisions it did.
That's amazing. It's like being able to read the AI's thought bubble. But even with transparency, there are still challenges, right? Like, how do we ensure that these AI systems are used ethically and that they don't perpetuate existing biases?
Those are really important questions, and they're ones that the authors of the paper grapple with as well. They believe that ethical considerations need to be at the forefront of AI development. It's not just about creating powerful AI, it's about creating AI that benefits humanity.
So it's not just about the technology itself, it's about how we use it. It's like any powerful tool, it can be used for good or for bad. This has been such an eye-opening conversation. We've covered so much ground, from the technical details of the o1 model to the broader societal implications. I feel like I've learned so much about this new era of thinking slow AI.
Me too. It's a really exciting time to be following this field, and I think the authors of this paper have done a fantastic job of not only explaining the technical details, but also highlighting the bigger picture.
Absolutely. It's clear that they've thought deeply about both the opportunities and the challenges that come with this kind of AI.
Hmm.
As we wrap up, is there anything else you want to add?
Well, I think the key takeaway is that we need to be having these conversations, you know? We
Yeah.
need to be thinking about the ethical implications of AI and making sure that it's developed and used in a way that benefits everyone.
Absolutely. It's not just about the technology itself. It's about how we choose to use it and what kind of future we want to create. But I am curious, what kind of future do the authors of this paper envision for o1 and models like it? What are some of the potential applications they highlight?
Well, they're pretty optimistic. They see this thinking slow AI as having the potential to revolutionize a lot of fields, you know? Like scientific research, for example.
Oh, yeah. How so?
Well, imagine AI systems that can help scientists analyze massive amounts of data, identify patterns, and even come up with new hypotheses.
Wow, that would be incredible. Like having an AI research assistant working alongside you.
Exactly. And it's not just science. They also talk about potential applications in law, medicine, education, finance. Pretty much any field that requires complex reasoning and problem solving could benefit from this kind of AI.
It's really mind-blowing to think about the possibilities.
Yeah.
But I also keep coming back to this question of jobs. If AI can do all these things, what happens to the people who currently do those jobs?
Yeah, that's a valid concern, and it's one that the authors of the paper address directly. They believe that as AI evolves, we need to focus on developing skills that are uniquely human.
Like what kind of skills?
Well, things like creativity, empathy, critical thinking, skills that are difficult to automate.
So it's not about competing with AI, it's about finding ways to collaborate with it and leverage its strengths while also recognizing the value of human skills.
Exactly. It's about finding the right balance. And I think that's a key message that we need to be emphasizing as we move forward with AI development.
I couldn't agree more. This has been such an insightful deep dive. I feel like we've really gone deep into not just the technical details of o1, but also the broader implications of this new era of AI.
Yeah, it's been a great conversation. And I think the authors of this paper have really done a service by sparking this kind of discussion. It's so important for us to be thinking critically about the future of AI and how we can shape it in a positive direction.
Absolutely. Well, thanks for joining us on this deep dive. It's been a pleasure as always. And to our listeners out there, we hope you found this episode thought-provoking. We'll be back next week with another fascinating topic, so be sure to tune in. Until then, keep those minds curious.